Okay, so let me right up front here as I start 10.1b say this. We don't want to give anybody an excuse to not go to revival. And even though students would have all Friday and all Saturday to do their homework, we still don't want them saying to their parents Sunday night, I didn't get my homework done, I got to stay home. For that reason, this is the homework, and anybody that is at church Sunday morning and Sunday night, if you don't want to, you don't have to do the assignment. Now again, I only give homework because you need it to help you to learn the concepts. But you don't have to do it if it's going to keep you out of church Sunday morning, Sunday night. Now if you don't go to church Sunday morning, Sunday night, our church, then it doesn't matter, you got to do it anyhow, all right? But if not, if you don't want to do it, you don't have to. I'm not going to give you, I'm not going to give you a 0, I just won't give you a grade for it, all right? You follow? Because again, we're trying to make sure that people don't stay out of church for ridiculous reasons. All right. Probably said too much already. Here we go. All right. With the 3 basic ratios comes what are called the reciprocal ratios. Reciprocal. So there are really 6 trig ratios. However, your calculator only includes 3 of them, because if you have the 3 of them, you can figure out the other 3. And that's what this is about right now. All right? So, reciprocal is 1 over something. So the sine has its reciprocal function. That is the same as 1 over the sine. All right? Reciprocal is 1 over. So the way it goes here is the reciprocal of the sine is the cosecant. The students want to say, why isn't it the sine, or the cosine? Why isn't it sine and its reciprocal cosine? And there's reasons for that. There are other relationships as well. But notice sine, and then the other one has a co with it. So it's cosecant and sine. So the cosecant of x equals 1 over the sine of x. In abbreviation, it's usually CSC for cosecant. Now again, you don't have a calculator button for this because you don't need one. So if the sine is the opposite over the hypotenuse, the reciprocal, right, the flip of that is the hypotenuse over the opposite. Right, the reciprocal. So the sine is the opposite over the hypotenuse. The cosecant is the hypotenuse over the opposite. Okay, it is the reciprocal relationship. So, because the cosecant equals 1 over the sine, then the sine would equal 1 over the cosecant. And again, if they give you an angle, include the angle. The sine of angle x equals 1 over the cosecant of angle x. 1 over the sine of theta, theta is an angle designation, equals 1 over the cosecant of theta. Right? So if there's an angle included, include the angle. If they just say sine equals 1 over, just put cosecant. If they say sine x equals 1 over, then you got to say cosecant x. So they're reciprocals of each other. Cosecant equals 1 over sine, the sine equals 1 over the cosecant. Do you have to memorize the cosecant? Well, you shouldn't have to if you know that it's the reciprocal of the sine. If you know the sine is opposite over hypotenuse, then the cosecant is obviously hypotenuse over opposite, if you understand that relationship. And that's usually the way most would deal with it. So there's 3 of them. So the second one is with the cosecant. And so notice we already have a co. So its reciprocal is the secant. So the secant equals 1 over the cosine. And because the cosine is the adjacent over the hypotenuse, the cosecant would be the hypotenuse I'm sorry, the secant, right, would be the hypotenuse over the adjacent. Ha ha ha. Laugh out loud. Right, the reciprocal. So you got to know, hey, sine and cosecant, cosine and secant, reciprocals. So the secant is 1 over the cosine. Abbreviation is SEC. It looks like SCC. It's SEC for secant equals the hypotenuse over the adjacent. And so just like the sine, therefore then the cosine of x would equal 1 over the secant of angle x. Right? Things that are reciprocals of each other. So the secant equals 1 over the cosine, and the cosine equals 1 over the secant. Marissa?
Is it SEC or SCC?
SEC for secant. It's the first 3 letters of secant. SEC. Yeah, I made it look a little bit more like an E because it looked like a C. Remember, try to go by what you hear, not by what you see. All right, it is an E. All right, and then the third one, these go together. So the third one a little bit easier, and that's the cotangent. And the cotangent is 1 over the tangent. And the abbreviation of the cotangent is COT, though we don't say cot. We don't say the cot, all right? Oh, the cot. Just like we don't say sin, all right? And we don't say cause. We say cosine, we say secant, we say cotangent, not cot. All right, and so the cotangent, all right, so what is the tangent? Opposite over the adjacent. So what's the cotangent? Flip it, right? So it ends up adjacent over the opposite. And because the reciprocals then, the tangent of x is 1 over the cotangent of x. 3 reciprocal functions. Well, here's the thing. They're not on your calculator. Unless, of course, these days, who knows? There might be a calculator out there that has it in there. Used to be calculator buttons were limited and memory was limited. You only had limited space. So they could only put so many things in the calculator. And they didn't bother with these other 3 because you can figure them out. I hope calculators today still don't have them, because all that happens is when you can do too much with your calculator, it just dumbs you down. You really don't understand what's going on, and students should understand what's going on. Anyhow, I don't think your calculator has them, but then again, I wouldn't put it past anything these days. All right, so how do you now find the ratio in decimal form when given the angle? How do you find the ratio in decimal form when given the angle? Because before we're just hitting the calculator button, right? Hit the sine button for the sine of the angle, hit the cosine button for the cosine of the angle, hit the tangent button for the tangent of the angle, but you don't have those buttons. So we have to use the reciprocal ratio to get us there. Okay, so if they ask you for the secant of 70 degrees, right? You're going to use the reciprocal ratio relationship. And so you would then say this, oh, the secant of 70 degrees equals 1 over the what of 70? Cosine of 70. And that is what you're using your calculator to figure out. Now be careful. You can do this 2 ways. You can do cosine of 70 and hit your reciprocal button. Your reciprocal button either looks like a 1 over x or an x to the negative 1. You have it on your calculator. So you can do cosine of 70 and then hit your inverse button. Of course, calculators today, sometimes you got to do the inverse button first. It's a pain. Or you can do 1 divided by parentheses, cosine 70, close the parentheses, and hit enter. Either way, but you got to figure out how to get the right answer. And if you punch it right, you should get 2.9238. So make sure you're able to get 2.9238. Jeff?
You're saying use the cosine like the negative 1?
No, 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 no. Not the cosine of the negative 1. Not at all. That's a whole different function. The cosine button. See, this is cosine 70. 1 divided by the cosine of 70. 1 divided by the cosine of 70. The reciprocal of the cosine of 70. Not the cosine of the negative 1 button. Everybody getting 2.9, etc.? Everybody good? Joanna, you're not back in radians again, are you?
No,
Okay.
instead of doing the reciprocal, it's okay if you just put it in a factor form, right? Like in a fraction form.
Yes, you can do 1 divided by same thing. That is doing the reciprocal in that fashion instead of using the button. Okay, 1 divided by. But you got to remember it's 1 divided by. It's not so bad if you remember what you're doing. Because see, again, here's the point. This is the button you have on your calculator. So we're able to do the secant of 70 degrees or of any angle by doing 1 over the cosine of that angle. That's the point, Luke.
So, they gave us like a triangle, and it asked us to give us the secant of an angle. Would it be like 1 over the ratio of the cosine?
Yes, so remember, they could either ask you for the ratio in fractional form off the sides of the triangle, at which case secant, you would be doing the hypotenuse over the adjacent.
Oh,
But if they are okay with it being in decimal form, if you know the angle measure, you're just punching in 1 over the cosine of that angle measure. Okay? Remember, this form, look, this is the hypotenuse divided by the adjacent, divided out in a decimal round off. You got to keep that in your mind all the time. This is secant hypotenuse divided by adjacent for a 70-degree angle. Every right triangle that has a 70-degree angle, the hypotenuse divided by the adjacent is 2.9238, every single one, because they're all similar triangles. Okay, so go ahead and see if you can do these two. I'll do them up here while you're doing them. If you can follow the example yourself, go ahead. If not, look up. But at the point where you think you can do it yourself, go ahead and do it to yourself. So again, you're just thinking, what is the reciprocal ratio of it? You got to make sure you're punching it correctly. All right? And there's all 3 possibilities, right? Secant, cotangent, cosecant. That's the way it's going to be every time, Marissa.
Mine came out the square root of 3 plus 2.
Okay, hit that button again. Again, yours is giving it to you exact. Okay, your calculator's too smart for itself, unfortunately, but that's the way it is. All right? Any other questions? Everybody good on that? Okay, look, here's the key. You got to remember this. First quiz, this stuff will be on there, and you got to remember this. So you might want to put an asterisk here, because later on, we'll figure out how to do it the other way, where we'll know the ratio and we'll go backwards and figure out the angle. That's a little bit trickier. It's the same use of the reciprocal function. Okay? All right. So then that leads us to degrees, minutes, seconds. Degrees, minutes, seconds. Some of you guys, as you found out last night, you have this button. Now, every calculator has degrees, minutes, seconds. It's just some calculators, it's buried in a menu somewhere. And who knows where that menu is. And the other thing is you have to figure out what the syntax is for your input. In other words, how does your calculator want you to input something to get it to output it in the correct form? And sometimes you have to know how to read the form. I'm going to show you how to do these mathematically. I'm fine with you using your button, though. But I'm going to show you what the math is going on with degrees, minutes, seconds. Now, In nautical concepts, degrees, minutes, seconds comes into play. In aeronautical concepts, it's just another way of thinking of an angle. Look, I could say 10.5 degrees, or I could say 10 degrees, 30 minutes. How is 30 minutes 0.5? Well, look, 0.5 is a decimal system based on 10, right? And 5 is half of 10. What's half of 60 minutes? 30 minutes. So 10 degrees, 30 minutes is 10 and a half degrees. That's the basis of it. Say, why do they do this to us? They just want to drive you crazy. That's all it is. You know, it's the way they used to think back then, and they still use it today. It's no different than the metric system and the British system. It's just another way of looking at the same thing. And so we need to understand that. And you will come across problems with degrees, minutes, seconds. So, again, let me try to get you to understand. So this first example, 54 degrees, 30 minutes. Okay, what is that? 54 degrees, 30 minutes. There's 30 minutes in an hour. So really, the 30 minutes part, if you want to convert to decimals, is a 0.5, right? So if you want to convert 54 degrees, 30 minutes to decimal form, it would be 54.5. Right? And now we're in degrees, and I'll stick the degree symbol, although we don't always use the degree symbol anymore. Okay. It's not so bad when they just give you degrees and minutes. Because again, all you do is take the minutes and divide by 60. So again, if they had 83 degrees, 10 minutes, that's a piece of cake. 83 degrees plus 10 divided by 60. 10 divided by 60, so you end up with 83.16, and I'm putting a bar. If you were going to round this off, you might round it off to 83.17, right? Because it's 166666666. So round off. Again, just divide 10 by 60. You get the 0.166666. Still have 83 degrees. 83 degrees. 83.16 degrees. Okay, so what happens if you got seconds? Let me get rid of my shade so I can go higher for you guys. So what happens if you get seconds involved? Okay, well, here's an example where you got 12 degrees, 30 minutes, 15 seconds. The 12 degrees is just 12 degrees, right? That's straightforward. 30 minutes, like we just did a minute ago, is 30 divided by 60. But you can't say for the seconds it's 15 divided by 60 because the whole decimal part is in relationship to hours. See, when I did 30 divided by 60, I'm going in relationship to the degrees, quote unquote, the hours. Hours, minutes, seconds. Degrees, minutes, seconds. So by dividing it by 60, I'm in relationship to hours. How many seconds are there in an hour? 3,600. And that's why the seconds are divided by 3,600. Because again, it's got to be in respect to the hour to make that decimal part correct. So again, your calculator will do all this for you if you figure out how to do your button. But if you don't know how to do your button, then this is what you're doing. So what would you do with a problem like this? You would take your degrees. They're going to be 74. You're going to get 74 point something. You would add to it 22 divided by 60, right? The minutes divided by 60. And then you're going to add to that 50 divided by 3,600. And you just got to add up the parts. You're just adding up the pots. So here, I'll do this one in red. This was what, .366. And this was 0.61388. You got to say, where do you go to? Usually 4 decimal places. It's just hard. Everyone's a little different, right? And where are you going to round the thing off? So if you add all this stuff up, you get 74.3799 degrees. We're going from degrees, minutes, seconds into decimal degrees. From degrees, minutes, seconds into decimal degrees. So it's the minutes divided by 60 plus the seconds divided by 3,600. Again, if you figure out your button, you got to figure out how to input it. I think you do 74.2250, I believe, and it'll do it for you with a button. But again, every calculator is a little different. Luke,
I got a different answer.
what'd you get?
Well, I got 74.38055.
Anybody punch it in with their calculator?
Because it's supposed to be 0.01388.
Oh, there is an O there. Okay, thank you. Yeah, that's not a 6, that's an O. Thank you. No Kool-Aid for David. 0.01388. Luke, again, if you would divide 50 by 3,600.
Yeah, I did.
So 0.01388. So 0.366. Is this, okay, it's 22 divided by 60. Is it 0.366666? See, I would be doing this all in one shot in my calculator. I wouldn't be breaking it up. This would all be one thing in my calculator so that I'm not worried about any round-offs. All right? So I would do 22 divided by 60 plus 50 divided by 3,600 and read that decimal answer to 4 decimal places. Better? All right, maybe I wrote a wrong number, so that's possible. Definitely possible. Where's my calculator? No, that's not mine. Somebody left that. All right, every calculator is different. I don't like this calculator. Using it this morning. Brother. All right, so anyhow, look, I'm not going to take the time. It is what it is. Take 22 divided by 60 plus 50 divided by 3,600. What do you get? Anybody get 74.3799? I just want to make sure it's not Luke. Okay, what is it? 74 point what?
3.
Okay, one person. 74.3055, so 0.3806. Okay. I agree, whatever. That's fine. I can punch a wrong button just like you guys can, so be careful. Be careful, be careful. But again, if you have the button and you figure it out, that's what it's doing. It's taking the minutes dividing by 60, it's taking the seconds and dividing by 3,600. And let me say this one more time. I would do that as one computation in my calculator so that I don't round off a round off. See, if you round this part off and round this part off and then add the two up, now you're getting a little further away from what might actually be those last few digits. So do it at one shot in your calculator. Right, the other way, now you got to think backwards. All right, how about go the other way, converting from decimal form to degrees, minutes, seconds. Okay, so first off, let's do the easy one. 7.5 degrees is 7 degrees and 0.5 of 60 minutes, right? Because we got to go to minutes now. So this is pretty straightforward. You're going to multiply 60 minutes by 0.5. That's pretty easy. And you're going to get 30, right? So this thing ends up 7 degrees, 30 minutes. Minutes is 1 slash, seconds is 2 slash, right? We know that. Minutes is 1 and seconds is 2. So by the same thought then, what if you have seconds involved? Well, again, this gets a little trickier. Now we got a little bit more to deal with. All right, so let me go slow on this one. That's at least as slow as I can with the time I've got. Look at our decimal part. 0.6015. Oh, brother. You have to take that whole amount and multiply it times the 60 minutes. You just don't take the 0.60. You got to take it all, 0.6015, and multiply it times the 60 minutes. All right, so punch that in your calculator. What is 0.6015 times 60? Okay, 36.09. I'm going to write it underneath. Is everybody okay with that? Okay. So now I have to take that decimal remainder. I have to take this 0.09. But look, I've already done 60 minutes. And it's the remainder, the decimal part of 60 minutes. So now I only do times 60, not 3,600. Because I'm already using now a decimal off of a multiplying times 60. So it's the remainder, 0.09 times the 60 minutes. And on that one, did you get 5.4? So what would your final answer be? All right, how many degrees do we have? 11, right? I'll do the minutes in green. How many minutes did I have? 36 minutes, right? And the round off of the minutes left me 5.4 seconds. This is what your calculator button would be doing. So the trick there is you got to use the remainder of your minutes and multiply that by 60 to get your seconds. Remainder of the minutes, multiply times 60 to get your seconds. Not too bad once you do it a couple times. But off the bat, it's like, I don't know, what am I doing? Okay, so here's one more. Again, why don't you try to do it, and I'll be up here doing it while you're trying to figure it out yourself. Where's my calculator? I really hate this tool. All right, so did you end up at 44 minutes, or 44 degrees, I'm sorry, surely you got that part right. 13 minutes. Most people would just put 32 seconds. If you want to put 0.0, I'm fine with that. How many got that? It's not so bad because you're following what you're doing, but okay, how are you going to remember this? Oh yes, I'll never look at this ever again, and I'll remember it come test time or quiz time, because I'll never ever look at it again. I'm not remembering it without looking at it again. I got to sit down and figure it out every time, because this isn't something like that's always in my front of my memory. But I know there are 60 minutes in an hour and 3,600 seconds, and I got to remember the other way, or I use my calculator button. All right, a few people came in, so let me give my speech one more time. So because of revival, we don't want any student to have this excuse, though you should do your homework tonight or Saturday, and come on the Sunday and say, Mom, Dad, I can't go to church Sunday night because I have homework to do. So for that reason, Anybody that goes to our church Sunday morning, Sunday night for the revival, if you don't want to do your homework, you don't have to. I think you should get it done. It'd be best for you, but you don't have to, and it won't go against your grade if you're in our church Sunday morning, Sunday night. Okay? You don't have to. I will go over it Monday, but again, if you don't do it, you don't have to if you're in our church Sunday morning, Sunday night. Joanna.